we present Painted, text-to-texture synthesis via deep convolutional texture map optimization and physically based rendering. I'm Youwang, and this is a joint work with Tae-Hyun and Gerard Ponsmo. Imagine you're a graphics designer who makes 3D games or movies. You want to build an immersive virtual world with realistic and diverse 3D humans, objects, and animals. Fortunately, you have a set of high-quality 3D meshes. However, you only have a very limited set of available texture maps, or only the 3D shapes without texture. How would you like to paint these untextured 3D meshes? One could model the texture maps by using commercial graphics tools. However, handcrafting high-quality texture for meshes is time-consuming and labor-intensive. In this work, we propose Painted, an automatic, text-driven texture synthesis method. Given a mesh without texture and user's text prompt describing how they want to paint the given mesh, Painted synthesizes high-quality PBR texture maps for 3D meshes. Regardless of the semantic category of the mesh, you just need a simple text prompt to paint it. There were some prior works that tackle similar tasks, where they synthesize RGB colors using diffusion model-based image inpainting. The results might look reasonable, but the iterative image inpainting leads to undesired artifacts, where multi-view inconsistent textures are synthesized. Furthermore, most existing works focus on synthesizing RGB textures, limiting their practical applications such as mesh relighting. Although a seminal work, Fantasia 3D, synthesizes per-point PBR materials, their representations are local, which leads to undesired texture jittering artifacts. On the contrary, our Painted can synthesize a realistic, multi-view consistent, and smooth PBR texture maps, which could be applied to practical test-time applications. Painted is a text-driven PBR texture map optimization system. Given a 3D mesh and a text prompt, Painted first texturized the mesh with initial PBR texture maps, composed of diffuse, roughness, metalness, and normal maps. Then, we performed the multi-view mesh rasterization using a differentiable rasterizer. To update the PBR texture maps, we leverage a pre-trained text-to-image diffusion model and compute the guidance via score distillation sampling, called SDS. As the optimization proceeds, each material map gets updated to match the text guidance. Note that our optimization is dedicated for a single 3D mesh, thus synthesizing a well-crafted PBR texture maps for a single mesh. Our major contribution is on our investigation about the PBR texture map representation. We propose a novel PBR representation called Deep Convolutional PBR Texture Map, DCPBR. We propose to reparameterize the PBR texture maps into a randomly initialized deep convolutional kernels. Given a randomly initialized unit T theta and a fixed input noise Z, we obtain the explicit PBR texture maps by feeding the input noise to the unit. Going back to our texture synthesis pipeline, we simply change the optimization variable from pixel values of PBR texture maps into the neural weights of unit T theta. The rest of the optimization remains the same. Interestingly, in our frequency analysis, we observe that our DCPBR naturally induces the coarse-to-fine frequency scheduling when synthesizing textures. The baseline pixel optimization increases all the frequency bands despite the TV regularization loss. Thus, it fits high-frequency noises from the SS gradient. On the contrary, our DCPBR optimization naturally performs frequency scheduling and learns low-frequency bands faster than the high-frequency noises. Even with noisy SDS loss, DC-PBR achieves stable optimization and synthesizes smooth texture maps. Here, we visualize our textured meshes. The qualitative results show that our painted can synthesize vivid, realistic, and globally consistent PBR textures. Thanks to our proposed DC-PBR, painted shows superior quality of synthesized texture maps compared to the competing methods. As one of the practical applications of the synthesized textures, we demonstrate the test time mesh editing using popular graphics engine. We can relight the mesh by changing HDR environmental lighting and control the material properties at test time, even without resynthesizing the texture maps. Painted does not perform a remeshing process and preserves the original UV texture coordinates. Thus, we can synthesize texture maps for any rigged human meshes and create dynamic virtual humans from only a text input. To wrap up, we conclude that the better PBR texture representation sufficiently stabilizes the mesh texture synthesis even with the noisy SDS loss. We hope our painted can revolutionize the 3D vision and graphics field and the industry. Thank you for your attention.